Hey everybody, it's Tutor Justin, and we are continuing our series here on calculus. This video here, we're going to concentrate on what the hell a fucking second derivative is, and maximum and minimum, and um, how the hell we solve all that shit. So that's the video we have going today. I know some of you have been, I know I wondered this when I took my calculus classes. I'm a nerd. I like all things math. It's just one of those things about me. That's why I'm doing this. But I understand why some people are like, why the hell do we need to use this? Why are we taking this class? Why do I even? I'm a communications major. Why do I need to take calculus? I'm a business major. Why do I need to take business calculus? Couple reasons. One, I don't disagree with you. There are a lot of majors that take this that I don't think really need it. I actually went into ChatGPT and asked maximum and minimums, what, and calculus, who actually uses it, right? And you get yes, you get the engineers, you get the computer sciences, you get the PhD, you get the economics, you get the statistics, you get all those nerdy things that they will use it because a derivative is obviously the slope of a line. It talks when you're talking about curves. A lot of the physics, a lot of those sciences really use it, and I understand. Even some architects use it when they have to. But the thing is they don't do it by hand. They have computers that do it. They have they all just really need to understand what the concepts are. And I don't think at all that they teach the concepts of what the hell a derivative actually is at all very well. I don't think they teach it well at all. Not even a little bit. I think professors kind of, some of them, just most of them just gloss over and say, you need to learn the power rule, the chain rule, and the quotient rule. I need to know how to do all this. But they don't tell you why and what it's actually doing. That is I think, a big disconnect, because when you understand why you're doing it, you're like, all right, because I understand you have to do the long way before you can do the short way. You have to do the long way to do the math in order to understand what the computer is actually doing. I get that. That will help you explain, that'll help you learn a little bit better. I'm a big proponent of that. That's good. But they don't really tell you the overall concept of optimization. Why do we do it? Oh, we're trying to be the most efficient. Yes, we're trying to, in theory, yes, businesses always are trying to optimize, trying to maximize their revenue, minimize their costs, trying to optimize operational efficiency. Yes, they are going to do that. And just trying to explain those and just trying to explain, just the professors don't do a good job of explaining it. And I think that they do a disservice. So that's my rant of the day about that. So again, this section here, this last series, or this, we'll do an application. We're not quite there yet. I think I have two other videos, and then we'll do an application. But we'll do an application and an overall, just what a derivative and all what the reasoning of a derivative is, and what the concepts that we learned. Just a general, no math, no anything, just what the hell they are video. And we'll see how ChatGPT does. I have a feeling it's going to do a pretty good job. So, without further ado, this will be the start of our part 3 of our series. All right, here we go. Okay, so we are on our derivatives for our calculus series. Here, this is part 3 of our derivatives, and as you can see here, we have second derivative, we have maximum or minimum, we have a profit function. On a separate sheet of paper, at some point, I'm going to take a picture. I wrote down practice problems, or my answers for each of them, each 1, 2, and 3, just to see how it checks your work. This one's going to be pretty heavily directed towards checking work. We'll talk a little bit on each of them on how ChatGPT explains how to find the second derivative, what it actually is, and how to determine if it's a local maximum or minimum, and then the optimization. We'll do a how-tos, but we're going to focus a lot on can you check my work, because the process on all of these are pretty close to the same. Taking our derivative, second equal to 0, taking a derivative of a derivative. We've done a lot of derivatives. We did a lot of how-tos on derivatives on the previous videos, so this one will be really heavy on checking the work. And as previously stated in other videos, I understand that not many professors give paper homeworks anymore, practice problems anymore. It's majority of it, the vast majority of it, is all online stuff where you have to answer multiple choice questions, or B, just write in what the correct answer is. Find the second derivative. So you just write in the second derivative. Do I agree on all of that? No, I don't. But it's how they do it, and it is what it is at this point. So this is why there's a need for ChatGPT, because it does a pretty good job on checking how you're doing things and how to write them and what work and where you went wrong. You got to ask it. You got to prompt it. You got to ask. She can be a little finicky, so you got to ask it correctly and kind of guide it through sometimes. But overall, again, it does a decent job. So let's get this started. You want to pause the video right here and write down what those functions are. I'll try to put them in the description, but for the most part, I'll just be referencing them, and we'll go from there. Let's go to Calculus Derivatives Part 3. So I uploaded the file already. And again, you could it's uploading it and doing copy and pasting, same thing. It's just, for this video's sake, easier to upload the PDF. But it's the same thing as copy and pasting. The hard part is sometimes with copy and pasting, that's the next update that ChatGPT really needs to do is, can you please put some math editor or math symbols or something inside this keyboard here so you can easily reference math. Look at I think that's like symbol calculator, or Wolfram Alpha. Those have some type of math keyboards that you could put logs, you could put fractions, you could put square roots, do all of those function type things, and you can write them in there. This not having to it can be a little tedious. So let's start here, and first we have to take a second derivative. What is a second derivative? So I'm using the Math GPT, so let's see how good it does. Can you go over what a second derivative is and how to find it? Okay. So absolutely diving into the world of second derivative is like unlocking a new level in a game full of twists and insights into the curvature and acceleration of functions. What is the second derivative? In the grand adventure of calculus, I like how it is. It's very storyish and not so much, hey, math, we're going to shove formulas down your fucking throat. So it's telling it like a story. All right. Denoted as f of x, d of f of x. I know it's f prime x. There's like 75 different ways of symbolizing what a derivative is. It's like the velocity of an object tells us how the function is changing at any point of x, its rate of change. So, all right, the slope of the tangent line into the curve at any. Now the second derivative, d squared dx squared of f of x, is the derivative of the derivative. So the second derivative. Right, cool. It's like the acceleration of the function at any point. If the first derivative tells us how the function's rate of change is moving, the second derivative tells us how that rate of change itself is changing. In a way, it's a rate of a meta rate. Cool. How to find the second derivative? Find the second derivative by start by finding the first derivative. All right, so it gives us an example, x cubed. First derivative is 3x squared. Second derivative of that, so it'd be 3x squared, which would just be 6x. Cool. Interpretations of the second derivative. Now we're talking about concavity. There is a lot. Concavity. The second derivative tells us about the concavity of the original function. If the second derivative is greater than 0, the function is concave up. Smiling. So if it's smiling, it's concave. If it's less than 0, it's concave down. Frowning. Oh, that's a cool way to positive. So it's smiling, so it's increasing. The second derivative is frowning, so it's decreasing. Okay, inflection points. An inflection point is where the function changes concavity. Okay, it occurs where, so the slope of that equals 0. Cool. That's cool. Now, let's look at my answers for number 1. They're wrong. Bear with me. And let's see how it reads it. All right, so I uploaded my solution to number 1. Can you please, always use please and thank you, go over my answer? Some people have asked me, how do you use ChatGPT with like the combination? Is it always on your tablet? Is it on your phone? Is it on your browser? Well, how do you go about using it? So for this sake, 100% my tablet. I take a picture and I just type in there. It's an iPad. It works very well. I would probably use that the majority of the time. My second way of doing it is I'll do a combination of my browser on my computer if I need a bigger screen, and then taking pictures of my phone. So you can open up the same chat on a different device and take a picture, and then you just have to, when you go back to the browser or whatnot, just have to reload it. So just refresh the page and it'll upload that photo and go right there. So let's go over on your work on finding the second derivative. You've provided the first derivative, 20x cubed minus 12x squared plus 6x minus 12. Then you provided second derivative, 20x squared minus 24x plus 6. Your calculation for first derivative is spot on. You applied the power rule correctly. Then you took the derivative of f of x. You multiplied the exponents by the coefficients and subtracted 1 from the exponent. Looks like your solution to the problem is correct. So it is not correct. So it did not read it well. So this is where you have to kind of look at it and say, actually, my first derivative answer was 20x cubed minus 3x squared plus 6x minus 2. So if the first derivative is wrong, the second derivative is wrong. So let's see, let's clear that slip and get the correct solution. So again, it didn't do quite a good job of reading my handwriting. And again, it's probably like 75% to 80% accurate, but that little 20%, what did I do? I just changed it there. And most of the time you can just look at it, the answer it gave, and go, okay, I see where I went wrong there. I actually put, instead of minus 12x, I put minus 3x. I forgot to multiply 3 times 4. And so it shows second derivative. So your original solution for the first answer was a typo, and the correct first derivative is that. Consequently, the second derivative you provided is indeed correct. All right, so it didn't quite do exactly what you wanted it, but it did a pretty good job of saying, hey, this is the correct solution. Kind of check to see where you went wrong. That kind of stinks, but let's see if it changes for number 2. Let's see it. I wish it could read it correctly, and you can be like, no, this is like, There's no point in arguing. If you figured it out, no point in keep going back and forth. You're like, okay, checked it. Now let's move on. All right, now let's move on to number 2. So it says, determine the points of which a function has a local maximum or minimum. So I put the first and second derivatives, and now I'm saying, what do I do next? Okay. Here is what I have so far for question number 2. I just have the first and second derivatives. I am not sure where to go next. A lot of people say, all right, I've done it. I took the derivatives. It's asking for local maximum or minimum. What do I do? How do I check it? I took the derivatives like we're supposed to. Now what? So this is the way to do it. I recommend going as far as you can and getting an answer. Or like, for example, this one is fine. Now you're going to ask it next to provide you a similar question, and then you go a little bit further. I don't recommend you stop and you go. You stop, only go a little bit, go as far as you can and stop. Try to go to the end. Try to get yourself, like if it's wrong, it's wrong. That's fine. This is when you're supposed to make mistakes. So it's before your exam, and that's all right. That's perfect. Nobody's like, this is practice, right? You're supposed to make mistakes in practice and not in the actual game, right? For problem 2, you've correctly found the first and second derivatives of the function. Cool. Now let's go over the steps to determine the local maximum. First derivative test. Find the critical points. Oh yeah, that's right. Where the local maximum, we set the first derivative equal to 0 and solve for x. Second derivative test. To determine whether each critical point is a maximum or minimum, or neither, we plug the critical points into the second derivative. If g of x is greater than 0 at the critical point, it's a local minimum. If g of x is less than 0, it's a local maximum. Okay. If g of x equals 0, the test is inconclusive. With your work, first derivative is that. Second derivative is that. All right. Let's proceed with the first derivative test. Solving for x will give us the potential points of maximum or minimum. Once we have the critical points, we'll use the second derivative to test each of them. So we have to solve for x here. So I know, so let's say you're having trouble, and let's kind of work it together. So to find the first derivative, or to find to solve for x in the first derivative, can we divide everything by 2? Looks like everything's divisible by 2. So you can have 2x cubed minus 9x squared plus 24x minus 4. Simplify that. All right. Now to find the current, we set this equal to 0. We can solve this cubic equation for x to find the potential. What would you like to go? Would you like to go ahead and solve this equation? So this we solved in our factoring video. We solved how to do cubes. So yes, can you please solve this equation? So it showed exactly using, I think we used synthetic division. We used a wide range of things. Since it's 2x squared, you're going to have to try 1, 2, or 4. So it's going to be a combination of those. Usually, it's either going to be 1's definitely going to be there. So 1 cubed is 2. 2 times 1 is 2. Minus 9 is 7. Plus 12. Well, 1 is not. Yes. Okay, so after solving this equation, we find the critical points are at x fraction equals 1/2 and x equals 2. These points at which the function g of x might have a local maximum or minimum. The next step is to use a second derivative to use these points. All right, so we solved that. It's going to be x equals 1/2 and x equals 2. The second derivative evaluated at the critical sign gives us, so that is plugging our second derivative, which we found up here. So we're plugging that 12x squared minus 36x plus 24. We're plugging in that 1/2 and that 2. So it's 9 and 0, 2 is 0, which is inconclusive with the second derivative test. So 9 greater than 0, so that's a minimum. Cool. For the critical point where x equals 2, we can't determine the nature of the point using the second derivative test since the result is 0. We might use a first derivative test around x equals 2 to determine if it's a point of inflection or classify it as other methods. Usually when it's equals 0, we call that an inflection point. So we have at x equals 1/2, it's a local minimum. Cool. Solved it there. And if you, again, want to go over how to factor using something to the power of 3, check out our polynomials. And we did all factoring. Polynomial video, checking out all factoring. So now let's go over number 3, profit function. All right, let's move on to number 3. I already done that. Let's take a picture. I got x equals 12. I purposely did this incorrectly. Again, it's negative 3x squared. This should be, instead of negative 6 or negative 3, it should be negative 6. So let's see if it catches it. Can we now move to number 3? I uploaded my solutions to that problem. All right, so we're moving on to number 3. And again, it is given the profit function p of x equals negative 3x squared plus 36x minus 100. So this is another optimization problem. We're talking about profit here, a business. This is a classic calculus, business calculus. Some economics is in here. I know in an economics course you're going to have to take a derivative of a function. So let's see. You found the first derivative and set it equal to 0 to find its critical points. Negative 6x plus 36 equals 0. Again, it didn't read it correctly. So solving this, you got x equals 6, but I see a discrepancy in your written solution where x equals 12. Let's correct it by solving the equation properly. After correcting the calculation, solving the equation, we find that the number of units that must be sold, x equals 6, not x equals 12, as initially noted. This is a critical point where the profit function could have a maximum. Now we typically use a second derivative to test or analyze the first derivative. However, since we have a quadratic with a negative leading coefficient, we can already conclude that this will give us a maximum profit. Would you like to verify this with the second derivative? So it's already saying, hey, it's a quadratic equation, it's a negative, we already know it's a maximum, which is a clue that you need to know. That is, you don't have to check it. You just know. Boom. But let's verify. Can you please verify? Boom. So again, it caught that x equals 12. Didn't do the best job here again of showing where it went wrong, but it showed you exactly how to do it, and you can tell that your derivative was wrong, and it got negative 6, and you can see that negative 3 times 2 should have been negative 6. We've done enough derivative problems that it's at that point you should be able to catch yourself. Because another way you need to be able to catch yourself on certain things like this, like it doesn't just give it to you, that's okay too, because you need to be able to solve it on the exam and be able to check to see if you've done it correctly. So it's just a good way, even if it's not there, just it at least shows all the steps of the correct, so you just need to verify what you did wrong there sometimes. And sometimes it'll tell you. So the second derivative of the profit function is negative 6 is a constant negative value. So you don't have to plug it in. Cool. This confirms that the critical point x equals 6 is indeed a maximum since the second derivative is less than 0. Therefore, selling 60 units maximizes the profit for the given quadratic equation. Cool. Or quadratic profit function. Thank you. Now, can you provide me with 5 similar questions to the uploaded homework practice problems? Can they each get a little harder in difficulty? So the hard part about a lot of exams is finding the difficulty level of the professor. No matter how hard you try, a lot of us are just like, you get to there, you're like, where the fuck did this come from? These are nowhere near the same level of difficulty that we went over in the homework. I personally don't agree that professors should do it, but they do. All right, they do it, it's okay. It happens, but this one will give you different practice problems, and it can vary the levels in difficulty. You can ask for it to be difficult, and as you read here, polynomial maximization, exponential growth rate. So as it says, e to the power. So if you don't have trigonometry, so you can say, thanks, but it looks like these are a little different than the ones we went over in class. We don't use trig, exponential equations. Let's say we don't use trig, we'll use exponentials, and we aren't at multi-variable derivatives. So you can tell them that. You're like, all right, it's not going to be perfect on the first one, but all right, well, let's go. We read those. We're like, we don't do any trig, and we're not at multivariables. So it aligns with single function or single variable polynomial functions and their applications. And boom, it gives you questions and questions. And you can go as long as you need to for studying, because a lot of times, even in the homework or in the notes, there's only so many questions that you can go over, and you already know the answers to them. Sometimes when you know the answers to everything already, we've done it a million times, it doesn't help you for the exam. What helps you is a diversity of questions, and this gives you a wide range of questions, which is exactly what you need. And that does it for part 3 of our calculus. And I think this next part, we will go over different applications and why derivatives are important and when the fuck you're going to use them. So stay tuned. Thanks again for the video or for watching. Please comment below if you want a specific topic you want to go over. It doesn't have to be math related. You could be any subject, stats, econ, sciences, biology, anatomy, you name it, we'll do it. All right, thank you, everybody. I hope everybody has a good day. Don't forget to follow me on X, like, subscribe, do the whole thing. Find me on X at the Tutor Justin. I hope everybody has a great day. Peace.